Myself, Mohamad Kamil. I'm here in NXP from the last 12 to 14 years, and then actually having total experience of working in this field around 20 years. Been intensively used on real-time simulations model, and what we call it as Simulink in the MATLAB. And then the NXP that we use for the development of any source code and anything for this any of the MCU application, we use MCU Expresso. And then we have a GUI tool for the debugging of your applications, which we call in FreeMaster. So I'll be doing a touch base on all these three. We'll show you kind of a hands-on experience we'll try to give you. For the MCU Expresso and the FreeMaster, we'll tell you like how it's been used and what are the features. We may not be able to touch all the features and everything, because it's like an ocean, but we'll try to give you the as much as possible that you will get familiarized with what is actually the MCU Expresso and the FreeMaster and how it can help you out in developing an embedded system code. And then we'll look into the Simulink, MATLAB Simulink, that how it's been used for the simulations and what we can do and what are the features we have. Along with that, with NXP, we have a tool called the model-based development tool based on the MATLAB simulation Simulink. We'll go through on this also, and we'll give you some hints like what are the things that NXP offers for their MCUs to, and how it helps to develop their final applications and all. Okay. So let's start with the MCU Expresso. MCU Express tools is itself as a complete tool. It provides you the integrated development environment and the IDE where you can write your own code and the embedded code to burn to the chip for the final applications. And to develop the code, you need to understand the MCU, its peripheral, the clocks and everything. So either you can have to go through all the 1,000 pages of reference manual of MCU and then start writing your own code for the peripheral initializations and everything. Um, that's the one way. Other way is good is like NXP provide you the SDK, software development kit, for each and every MCU that we have, where you don't have to go and read the reference manual. You can just follow this SDK and SDK example, and that gives you all the codes in the API format. So you need to just make it very user friendly and readable form of the code, where the user can develop their own code based on any of the MCU. And then to configure the MCU pins and all, that which pins, it'll just give an idea like in any MCU, there will be different pins, and each pin will be in a multifunctions. Like any of the pin could have ADC into it, and the same pin can be make it in a pendulum, or the same pin can be used as in a comparator input, or the same pin can be used in a GPIO, or same pin can be used in the fault detections and all. But you need to first define like which pin has to be configured for what function, and just is starting off your code. So for that, again, you do write a software for that, or then there is from the NXP, we provide an configurations tool where it's a pictorial representations where you can select each pin and define like, okay, each pin should be of what peripheral function, whether it's an ADC or the pendulum or the GPIO or the fault or whatsoever it is. So this is a very high level introduction for the MCU Express that we have. And then the ID and SDK and the configurations tool, all these sit together actually give you the complete sets of the environment that anyone actually look for when you go and start developing their applications based on any MCU, right? So before going into the detail in the presentations and all, I'll just try to take you the actually a real scenario, like how to start with, right? So this is the when you go into the NXP website, this is the link where you can download the MCUXpresso IDE. Right, there's a download button. There you can download the MCUXpresso IDE, and actually this has a lot of other documents too that you can go through it and can understand like how it works and everything. So from the NXP side, whenever you start to download any of the things, like most of the things would ask you for the login and password. So if you don't have any, then you can create based on your email ID, and then only it will allow you to to download those ID or any of the things that you want to download from the NXP. So you can hit download. So this is the one ID that you need to download to start working with the MCUXpresso. Actually, it will take a lot of times to download. So I have already in my laptop. Let me just go to that. Okay. So when you download this, you'll get this icon when you install, and the MCUXpresso ID actually you need to m- make in a workspace, and the workspace can be NXP. The workspace, you can make it any. You can keep it anywhere, wherever you want. That should not be of the same as where you kept your project. So the workspace and your projects can be of two different places. There's no issue. So wherever you feel comfortable, you can keep your workspace there. So let's say I have here, and then launch, and then it will actually launch the NXP MCUXpresso ID. There are a lot of background noise. Javed, can you just mute all the users? Okay, thank you. So when you open the Inspector, this is going to be the page, and where you have other links for the SDK, even how to create the new projects, how to import the SDK examples. Then you can click one by one, and that it will take you to the process where how to create a new project or the how to import an SDK and all. Uh, let's I'll just import one of the so that there is a this is the window that you'll open, and for that to import any of the projects, I'll explain in the later also that how you can do that. I'll just for the NXP MCUXpresso. Let's keep go 31. Okay, next. Okay, driver. So here you can see a lot of his uh, drivers, and the drivers actually based on all the peripheral that the MCUXpresso that the MCU is having. The MCU that will choose, or the board that will choose for the SDK, that will have all the drivers here. And let's say you can click any of this. Okay, so that will actually bring you the projects of that IMCU, uh, the example project of that MCU and the driver with the like we had we selected an SDK ADC. So this is going to be lookalike, and then a lot of buttons are there, which every buttons has their own feature that we can use. For that, let me just pull up something which is very useful here, and where you can show some example. Let's have this one. This is 1 minute. Let me this project. Let's open this one. Yeah, just any let's say the hello world. Okay, so now we have imported one of the projects called Hello World. This is the block that we see. This is called a project window where your all project files will be there. And then the left side, there's a debug window where you'll have all the links to for the new project or the import is in the existing projects or the build or the clean and the debug will be there. And here you'll have in this span, you'll have the source code that you're going to write or any project that you'll have would be here. There are there's this button is a debug where you can build the projects and burn those projects to your MCU. So this is your building the button. When you click this one, it will build the selected projects that you have in your project window, the selected one. And when you want to burn that projects to the MCU, you need to connect that the MCU freedom board or the tower card or your hardware. Then this is the button where you can when you click this one, then it will it build actually also as well as it burn the project into the MCU. So now you can see that it is looking for the hardware debugger that we can be used to debug the software. So we can select as an USB which I have connected to my board. Once that you burn the software to your MCU, then there will be a active the button will get active, which is resume. When you click that, then then the software will start running in your board, and when you click that and software is running in your board, and then there is a suspend button. It will stop the software whenever you click this one, and this is a terminate. When you click this one, then it will terminate your ID from the hardware. And this is this one. And now there is a window where you can see the global variable in your software. There will be a lot of variables that you will be having, which you would like to see in the real-time debugging system. So whichever variable that you'll define in the global variable in your systems, that you can look into here. Like just if I just let's say define as a clock, okay, and let's then stop it and let's rebuild and program again. Running. It's not showing. So let me add the variable which we just see. Oh, there's some error. We'll see later. No, sure. When we go to the next example, we'll see there. So this, as we have seen, like this is the project explorer view where you have all the projects files of your projects, and then quick start pan where you have all the debugging sites operations window will be there, and then the editor view where you can write your code and edit and everything. And then you'll have in below bottom, you'll have all this buttons where you have it will show that what are the SDK that you have installed in your IDE. If you build a code and there is an error, let's show you. It will show you that there is an error. Let me just make some error here in the code. Come on. I'll do some. I'll try to impose some error here. Let's say I'll just have something wrong here. I'll try to build a code. So there is this showing is an error, right? The console window will give you the error. When you go to the problem, then it will tell you like where all the errors are there. Like when you're writing any code for your applications, and if something wrong in your code, it is not as in line it's supposed to be, then it will throw out the error while building the code. So when you click to that error positions, it will show you like where the error is. And it on the times it also uh, show you some of the hints that what you need to do and what you not to do. So here, like like if we miss this one, so there is we need to put it here, and then when we correct that code and try to build it again, then the all error will go. So once when you build a code uh, and even shows zero error, then only you will be able to burn that code into your MCU. Until unless there is any single error present there, it will not allow you to burn your code into the MCU.
Got it.
Then you have a terminal block where it connected to the serial cable, and then you can see the serial communication from this terminal block. And let's say if you wants to search some of the variable in the MCUXpresso ID, then there's a search window. You can go click here, and whichever the file you want to search in the .c file or .h file or any of the file that is available on your project window that you want to search, or in the workspace that you want to search. So you can have a star, and then you search, and it will give you the all the places wherever that variable is there. And wherever you'll click, it will show you wherever the search was found. So in your code, whenever you are writing something and you want to know like any of the variables or anything that you have and you would like to see wherever you have placed those variable in your code, you can use the search global window, and that will give you that options. If and it will show you that where it is there. And this is the global search. Now, if you want to see only in the same file, the same file that is open, then you can look for this option, and it will look on this only on the same file wherever that file is open to your search, right? Let's go one by one. Search projects we have we have explained what is the build, how to build and all. So either you can go for the any software that you have, you want to build the project, either you can go the projects and the build, whichever the project that you have selected, it will build those project, or you can use the button, this hammer button, to build your projects. This is a configurations tool. I'll come later to tell you what other things are there. And then after the building the project, then there will be a run. You want to run that project into your MCU or the debug. So these are the options. Either you can go from here, or you can use these buttons to debug or run the software into the board, or you can use this button. So there are multiple options is there, whichever you are comfortable. You can use that. And there's a help window. You can if you are looking for any of the helps, like what is things are there, where are there, then you can always go for the help window, and and go and search there, and you'll get all the answer into the from the help window. Now let's okay. This is where there. Now the MC Expresso SDK, as we said, like we have the driver, the SDK for almost all the MCU, where it provides the preferred initializations, some of the examples code, and the drivers, everything for the your MCU NXP MCU of the Kinetis and the LPC series. Now let's see where how to download that SDK. So for the SDK download, there is again when you go to the MCUXpresso NXP.com, then you'll come up you'll land up in this page. For the like I have already logged in, so it is showing me the page is related to me. If you're a new user, then you to access this one, you have to first make your login, and then to register, and then you create a login, and then can come to this page. So this is the place where the previously downloaded SDK that you have from your login will be here. Or if you want to make any new, download any new SDK from the site, then you go here, and then it will give you the option like either if you know that for what MCU, the part number or the board that you know that for that you want to download the SDK, you can directly write it here, or there is a board which is all the board SDK which is available are listed here. So you can look into here that which are the board that you want to look into the SDK you want to download here. Like in the Kinetis part, for the Kinetis, what are the boards are available? You need to select which board SDK that you want to download. So whichever things are there, all are listed here. So like in a DSC part, there is all the board that SDKs are available here is here. And let's say if you are not sure about the board, like for which board you are going to use, let's say you want to directly download from the processor, then you can go to this link, and then you will see for the each and every the processor, there is all the processor would be mentioned here, that for whichever the MCU or processor that you want to download the SDK. Like for the Kinetis series, there's the E series, K series, K32, L series, M series, V series. So in V series, what are the MCUs are there? All the MCUs are listed here. So you can directly go to that MCU and download your SDK, right? Let's say go for the board and Kinetis. Let's say if so, it will later this board. I want to download the SDK for this board. So click here, then build and go build configuration. That options will come here, and then board configurations. It will show you the which are the board is there, which MCU is there, and which core is there. Like this is a Cortex M4 MCU, 120 megahertz, and the memory size and everything. It will give you to the informations. And let's say if I try to build a SDK for this board, now this see, there is an IDE like from the SDK side, the MCUXpresso, IAR, and the Keel. All the three IDE has been supported. So if you want to download for all, it will be there all. Let's say if you want to download for the only MCUXpresso IDE, then you can click here. So it will build the SDK only for the MCUXpresso or IAR. Let's say you want to download the or generate a SDK using an IR compiler IDE, then you can use only this one. If you don't want to download for the others or for the Kyle IDE that you want to download the SDK, then you can select only this one. Or let's say you are not sure like which IDE you are going to use. Let's download the SDK for whichever the IDE is available, And accordingly, whichever ID that you will use in future or are going to use, you can select those folders or the build. So you can select all. When select all, it will download the SDK for all the ID which is mentioned here. And then according then the OS system that you are going to use it. You're going to use it for the Windows computer or the Macintosh, the Apple computer, or the Linux-based computer, whichever the things you are going to use, you can select this one, right? And then you have the SDK and all that. What for the basic function that you want to use, CMSIS DApp library, all the library that you want to use, or the only motor control software library, along with the free master that you want to download, or all the SDK that you want to use. If you want to use download the SDK for the everything, then you can use the select all, and then it will select all the features of the SDK that is there and then download the SDK for you. And if you are then it will be a very big package. And if you are very sure like you are not going to use all this one and you only let's say you can looking wanted to have a SDK which is only for the motor control software because you are working on the motor control applications and you are not caring about the other one, the boot or the other one, then you can unselect all and can select only the motor control portions, and then it will download only for the motor control SDK. So if you just select all and then it will build the SDK for you, and then you have to definitely agree for that. If you don't agree, then it will not generate the SDK code and download. Okay, so I did that, and I do have in my I have downloaded before also. So I'll just go there and show you like see this access my SDK dashboard. In this tab, you will see what are the SDK that you have previously downloaded from that your ID, whichever ID you log in, and it will show you all the SDK that you have. If you go to show all, okay, show me all. Okay, so see it will just list down all the SDK that you have previously built or generated from your ID. So whichever the board or for the MCU, let's say for this few of the MCU that we have downloaded, I have downloaded for the SDK, generated the SDK for the board I have downloaded. So whatever things are there, that all will listed here. So let's say you have downloaded previously any of the SDK and you want to use again, then you don't have to download again. You can just go here and can download. And instead of again like downloading completely everything's you can have here, and then here you can see this download the documents or the download the archive one that you have, that you again have all the selections for you that whichever things you want to download if you don't want to download the complete one. And once you download the SDK, it will be just a drag and drop for your projects. Let's say for this, these are the installed. Next thing is that you have downloaded the SDK. Let's say I have uh, download. This is the one I have downloaded the SDK, right? And now how to install that on SDK? Either one is that unzip it and then install from there, or you can directly do the drag and drop. So actually, I have already this SDK here, so it may not take. It will give an error that is already there. I don't use SDK. I can. It's already there. So what I can do is I'll try to install the SDK for which I do not have. So I'll show you how to do that. Let's see which SDK I do not have. Okay, I have almost all. Let's download for the nearest DSC one. Let's go here. Select the board. Select board. Let's for the download for the DSC. I think this So this is one of the MCU from the NXP side. NXP offers MC 568200 series. For this is the tower board, and this MCU is especially designed for the power and motor control application. So I'm trying to build the SDK for this MCU to use that SDK for this board. So let's say this for the pre-master. It's a download. Okay. So to install the SDK, you can open you have to open your MCUXpresso IDE, and simply you can do drag and drop to here, and it will install the SDK in your IDE. Nothing this time because SDK was not created into the area. Your ID was not okay. So maybe like my ID is not up to date. I need to update the ID. So this is the way that you can install the SDK, whichever the board or MCU that you wants to install the SDK. So it will install like this. Okay, so you can see in my ID, I have these are the SDK, and already installed. And the other way to see like what the SDK that in your ID is there or you install, so you can go here and then click the import SDK examples, and it will show you that what are the board and the MCU SDK that is already installed in your IDE. And if in the board or the MCU that you wants to work and it is not showing here, it means those IDE, MCU or the board SDK you have not installed it to your IDE. So and then you can go to the MCU Expresso SDK builder and can generate your SDK and install to your IDE. So these are the board and all that we have I have already installed. So let's go to this board. And when you install the SDK, then SDK will have show you that what are the code examples it is there. So it is like SMC's driver example, you will see the peripherals, the LPU art, I2C, and the SPI bootloader examples that you can look into it. The component examples is there, then the demo apps. So these are the demo apps is there for this board. So let's say if you want to start working with this board, then this and to just to understand like how this board works and what are the peripherals and all. So you can look into that any examples code. If it is matching, then you can download those one. Or let's say you are interested only on the driver of that MCU that is placed in this board, and you want to download those driver SDK and start building your own projects. And you have all the peripherals that is there in MCU, their their driver examples. So you don't have to go and write a code for that drivers for that MCU. That's everything is here. You can download as per your requirements of that MCU that you want to use, and any of the peripheral that you want to use it. Let's say for the ADC, you want to use an ADC in interrupt mode. You can use distinct examples code, and then it will show you how the ADC. It will give you the one setup of the code installation code, which will show you how the ADC interrupt can be initialized or and write for this MCU. Or if you want to use an MCU into the polling mode, ADC into polling mode. In the polling mode, where you just poll the ADC when the conversion is complete. In interrupt mode, where whenever as soon as the ADC conversion is complete, it gives you the interrupt that ADC conversion is complete, and then based on that event that you want to do something else, then you can write your own code for that. So based on the requirement that you have, you can select those and can download. Or let's say for the demo apps, let's say download the Hello World and see how it goes. Come on. Okay, so this project is already there, so it may not. Okay, it's already there. So let me First delete and go for the beginning. Okay, so during this process, I'll show you one more thing. So this is this all this as I said, like in very initially, there's a workspace and there's a project. In a workspace, you can have a multiple projects. Okay, and you can work multiple projects in a parallel mode. And the all the every projects you can have an open project or the closed. This is open. If I open the project and this project is active, another project is closed. And in any given of times, the many projects can be in open state, but only one project will be an active state. Whichever you have active state, that project is active state, and that when you build or the try to burn the code to the MCU, the only that projects will be built and burned to the code. If I just close the projects, and if I try to delete, either you can go right click and delete. There should be option delete. So it is giving an option delete project on disk. If you take this one, then it will delete the project, the place where it was also, and it will delete the project from this workspace. So both place it will delete the project from this workspace as well as physically where in which locations you have in your computer this project. So make sure that whenever you are and if you don't want to delete the project from your hardware from your PC wherever you are it is placed and only wants to delete the project from the workspace, so then never tick this option. Okay, that's why this option is by default is unticked. Many times you would like to just reshuffle the workspace. You can delete the workspace every day that you worked. Let's say you worked it and then you'd want to delete the workspace, but you want to keep the project. So you can delete the workspace, and then next day morning you can again you can again reinitiate the workspace and import that project. But it means that you want to keep the project always there in your computer, then you never click tick in this option. So if I just delete it, it will just delete from my workspace, and this project will always be there. Let's see. It is oh, it is okay. So see, this project is there. It is not deleted from here. So this project is still here. So let me just delete it from here also. And import the new SDK project. So let's this one, go to the demo apps, hello world. So at this point of time, there was no project was there in my workspace, so it allowed me to open. And if it is already there, then it will not allow me to open because same project name in the same workspace, it is not it will not allow in any of the workspace. The two project cannot be the same project name. It has to be a different project name. So this is the hello world, and let's build that project. And let's debug it. Debug from this window. Now, whenever you do the debug, then the code will run and it will stop at the main. And when you do this resume button, then only it will start running the code. One more important point is here. Whenever you download or the import any of the project from the SDK, there you'll have a one folder called a doc, and there you'll have a README text. README text will tell you all the critical or the major point about that example or the projects. Uh, you can go through this and can see like what is that. Okay. So what is saying? Connect the USB cable between the host PC and the OpenSDA that I have already connected in my PC. And you can use a serial terminal or either from here, or let me just open any serial terminal from here, setup terminal. No, wait, it's got serial port. Okay, okay, 1 minute. Let me keep this so that you can also see. Okay, you can read it here. What is there? So it is saying go to this setup on serial port. It's saying open a serial terminal with the following serial port and then choose a baud rate of 11520, non-parity bit, 8-bit data, no flow control. Okay, perfect. 17. Okay, now it's saying download the program to the target board. Either press the reset button on the board and launch the debugger IDE. So if I just press it, you'll see the hello world here. So this is the example code. Whenever we place hello reset, you'll see that it's pushing in the terminal walk the hello world word, right? So this is one of the code example that is there. Let me just show you another code example so that you'll become more and more familiar with this. Let's import another example. Let's go with the LED blinking. Okay, let's build a project. Okay, one more things I'd like to just tell you here. Uh, I was doing something wrong, which is not the way actually to do that. Whenever you import any new projects, okay, so the first thing you should do before building the project is clean the project. What it does is any of the temporary path and all that project has saved, it will delete that. Otherwise, it could happen that when you build a project, it will try to pick those temporary paths, and if you don't find in your computer, then it will give you unnecessarily error, which is actually not an error. It is just because the temporary path was there, and that's why it is giving error. It is trying to pick something from those paths and those folders, and which is not there in your computer. It was somewhere else. Let's say you got some code from someone, from your colleague, right? And it has some other setting in your laptop. And when you open in your laptop in your computer, then when you try to build, then it will try to pick those paths which was there in the older version in another computer, and it will give you an error. So the first thing you should do is to right click and then clean projects. So it will delete all the temporary path which was there associated with this project, and then build. Then it will take all the path which is supposed to take from this project location which is there in your PC. Let's build. Okay. So again, the same thing. Okay, but I have the LED. So the LED blinking will be there. 1 minute. How to show that? Okay. I can show you by open my camera. You can see my camera, and you can see the board. So there's a LED is blinking. I just push that here, and I'll show you one more example, uh, which 1 minute. So ADC. Let me it import another projects. So from the same board, demo example. Okay, driver ADC. Let's say go with the ADC interrupt. Let's see what it says. README file. Pencil board. Okay, so J21. Okay, so now I have to connect. Okay, leave it from there. No issue. So another thing is the configurations tool, which is if you see this button, this is a configurations tool. When you click this one, it will open that MCU in a pictorial form that you can look into see it, and then each and every pin it will see like how it looks like, and what are the function is been associated with those that pin. Let just wait. Okay, here you go. See, for this the project which I was at this point of time was active. The two peripheral was being used, ADC0 and the UART, and it shows where all those pins were there and active. So if you see here, you can select like which pin. Let's say pin number 53 I want to use as an ADC0, and pin number 62 and 63 I want to use in a UART. UART will be, see if in this pin there are, it can be configured as a FTM0, it can be configured as a GPIO-B, but I want to, it can be configured as an UART. Or I want to use an UART, so I can select this one, and then it will configure this pin as an a UART pin. Or similarly, like the pin number 53, it can be used as a GPIO, it can be used an FTM1 channel, it can be used an ADC0. See the pins, several one pin can be used for the several functions is associated with this pin. So you need to define like, okay, it's pin number 53 used for which what function. So either you can go into the RM and look into it like how that pin needs to be configured and all, or you can open this configurations tool, and for each pin in your board, like which pin you want to use for the what functionality, you can select it here, and then you can update the code, and it will generate the code as per your as per your configuration, and it will update the board init pin. And the board init pin actually does it actually reconfigure all the pins of the MCU as per your requirement, as per your application, as per your configuration that you do. Here only the two peripherals are there. Let me just open one of the any of the big project where a lot of peripherals will be there. So then you can see how the more and more pin can be configured easily configured with this configurations tool. What is the example? Let's use PMSM model. PMSM. This is a code example where it has a complete source code for controlling the PMSM motor and FOC algorithms. So it uses a lot of peripheral from the MCU. We'll look into it like how those peripherals and which other pins have been configured for what functionality. So and build it. A 7. Okay, so you see the FTM has been used, the UART isn't used, GPIO and GPIO isn't used, and the ADC will also be used here. So you can see that the green highlighted one, the pins, which has been used for that applications, for the motor control applications, PMSM FOC control. So this is the a very high level overview of the configurations tool, how it can be used. You can directly here, so let's say you can to select here, let's say if you okay, I'll just show you. Let's say you want to this pin, you want to configure for what? Let's say this is 0. You can click here and it will configure that pin to that for that functionality. And if not the FTF0, let's say you want to use it as an a GPIO. So see the same pin or the same configuration function. If you go to the 2 pin, it will give us an error. And the red means is an error that you can that it will not allow. It gives an error. And along with the error, if you just keep the mouse cursor here, it will give you the what are the errors are also there. You can go, you can read that what it is saying and then correct in your code. Let's say if I just remove it, then it says fine. You can use that pin as a GPIO. It's fine, no issue. So that these things come into the can come into the picture when as one of it as any of the pin is associated with the many of the functions, and the similar way the same function is placed in the many of the pins also. Let's say ftm0 channel 1 would be in the many of the pins available, but you cannot make ftm0 channel 1 as a multiple pin. You have to make only one pin. So once you while selecting those or configure when you make the configuration of those pins, and if you make the ftm0 in the multiple channel, then it will throw you error that you cannot do that. You need to select only one pin for the one functionality, right? So this is one of the things, and it will help you out. Generally, if you just write a code, in writing a code, you may make the multiple as an ftm0, and then you may not get that error in your error window while compilation of the code, because compilation of the code only look for the your syntax error and all. It will not look for that if any of the pin you have done the multiple assignments. So you may not be able to debug that, but with this configuration tool help, it will help you out to make sure that you configure one pin for the one peripheral or one functionality to the only one pin. Neither the same functionality can go the multiple pin, or the one pin for the multiple pin. Either way is not possible. It will not allow you to do that. It will give you the error, and you need to correct it before. Then only it will allow you to move ahead. So that was about the configurations tool. Let's download the another topic which was there. It is the free master. Now, for the your debugging and all, we have. Come on. Okay. Okay. So there is a free master, which is a GUI-based debugging tool, which actually gives you the pictorial, or you can say it replaces your oscilloscope from your computer screen. You don't need an oscilloscope. You can see all the variable functionality inside your MCU running, like how the function, how the each and every variable is behaving during the run conditions into the GUI. Let me just give us example. So when the pre-master, like when you just go to the place where you have your projects. When you depend the project, then there will be a file called .pmp. .pmp. That is your free master files. When you double click, it will open this way. And again, as I said, like for any of the example project or anything is there, there is a README file. You just go to the README file and it will tell you that how to use that example code and what that example code does and what are the features and functions are there. So let's see what it says. So it says like connect the USB cable, compile and download the program to the target microcontroller, run and resume the application's execution debugging main. So let's build it. Okay, we have already built it, no problems. And let's compile and program our board. Okay, and what it says again. Run reference connection wizard. So go here. Okay, you can run this one. Go to the pre-master. There's a project option, and then you select this one and does OK. And there is a okay. Sorry, it's here. It is. That's why it is not allowing me to open. So I need to, because same USB cable I was connecting both, so that's why it didn't allow me to open. And let me reopen again. Option. Okay, so go here. It's connected. So now here, see. Okay. So there is a pictorial representation also you can have from the pre-master. This is like only show the how the variable 16 has been changed. There could be many things like in your motor application, the speed you can display here, or for anything like in a scientist application, you can display the load and the voltage and current everything here, how it's varying. Or those variable you can see in this window, variable watch window. What are the variable that is there in your code? You can see in your watch window like how it is varying in the real time. These are the going to the real time is varying. The other other is into the likeness, as I said, it can replace directly as your scope. So how the variable is varying, it shows in the scope, like how the variable is varying and when the code is running, how the variable is varying. So it's just an example. It shows very simple way that how it can be used in your complex code. Any of the complex code of, let's say, any of the example like in a motor control or the metering or the power conversions, or anything in the refrigerator, whatever things you can think of. If you written a code and you want to see the how your variable is varying with your code executions, you can put those variables here and can see how those variables are varying. This is on the scope. It means like whenever it is getting time, it is pulling those variables and throwing here to show in vectorial presentation. And then there is a called a recorder. Recorder actually give you the exact real-time position what is happening. Like in your code, there will be a two-way. One is something is running in the while loop where you don't define that exactly in this event that variable has to be changed, or you manipulate or execute those variables. There are some variables that you execute into the given event, which those variables you write into the interrupt. Like let's say you have some control loop running, and whenever you collect ADC samples, you generate an interrupt, and then in that interrupt you do calculation and execution of those variables to define the output, that what output should be based on the input that you have collected. So in then you want to look into that each and every the variable exactly at the point where it has been collected and how that execution is happening, that what the variable is behaving. Then you can keep those variables in the recorder, where recorder is collecting those variable in that event. A scope is actually it whenever the code see the time, it collect from there and it shows here. So it may not give you the exactly real time, that is how it's behaving, but in the average waveforms, average timelines, that how this variable is varying. So this is the pictorial presentation of the free master. It actually gives you the insight of your variable inside the code how is varying, and as well as it give you the pictorial presentation of the waveform that you want to put here, just to replace your oscilloscope. That also you can see that it can be done. You can do it in the oscilloscope format as well as in the recorder format. Uh, some more feature of the free master. Let me just pull one more example where you can see a lot more other feature of the free master before moving to the other topic, next topic, and let's close this one and import some bigger project. Let's say, oh, I already have. No, I don't. Yeah, it's already there. You don't have to. PMSM. Open project. Me just let there and run it. I have not connected the motor control board here, but let's see if how much functionality it allows me without connecting the motor control board, because it will give me the false and error everything's here. Let's disconnect this guy because now I need to open the free master of that project. It is here. Motor control control free master. Okay. You can see this. Yes, you can. Let's see. It has turned. Test there. Let's try to connect if it allows. Just give sometimes it will allow you to connect. Perfect. Wow. I wasn't expecting this, but good. It's there. So you can build a lot of things in the free master. Like it's really great tool. It's, as I said, like just replace your oscilloscopes. So you can define your parameters of the motor. You can put in there. You can calculate those parameters of the motor, and then you can define the control loops parameters. The speed loop parameters, then the sensorless parameters, then the control structure that you want to have. Like, and you can build your code, motor control code slowly. The control loop, the coefficients is start with the scalar control, then go with the voltage FOC, then current FOC, then the speed FOC finally, and then the output. It generates the output file and gives. You can see all this in the pictorial waveforms also, and the right side also, that what are the variable that you define that you want to look into it, that how it's varying. It will give you this also, that how this varying is system is, everything is. Here I have just listed down the variable that I was interested, but in your code, whichever the variable that you are interested to look into it to see like how that variable is varying, you can put it here, or you can have those variables here also. This is the graph. There you can actually do not have the motor connected. If I had the motor connected, then you can see the speed and everything. So these are the recorder, the phase current, the position, like how the each and every event, his phase current and the position. So the motor is varying, that you can look into it here. So there are a lot of options it gives. Like it's like a multiple scope in a one place. You can choose in between, and it makes your life much easier for the debugging of your code, especially if it is in a complex code and it is having a lot of relation with the hardware that you have. Not only the pure software, it's like hardware also play a great role into it. Then it makes life much easier when you use a free master, integrate a free master in your code. So that was about the free master. Let's see where we have reached. Okay, we are running. So we have gone through it, how to download the SDK and all these things, how to install the SDK also. We have seen this one configurations tool, that how the each and every pin and clock can do the pictorial way, and don't have to. And this is the link for to download all this SDK, MCUXpresso IDE and the free master. And there's a community where you can, for the each and every stuff, and wherever you have any doubt or any questions or any issue that you face, you can put those in the community. And then in the round the clock, the engineers across the globe sitting in an NXP can reply you for your questions that you have. And we have looked in the free master. This is like how the graphs and everything we can see, and it really helps in the embedded system applications development. Okay, now moves to the next topic. It is a Simulink that we are talking about. In generally in the hardware, whenever the software related to the hardware and all, and sometimes only the software and all, then and if hardware is complex and you don't want to make your hardware go bad in very first burning of the code or running of the hardware, then you would like to first simulate that hardware and see like if things are working fine, then only you will start and power on those hardware and all, right? So for that, there's a big tool called the MATLAB, where you can have simulate a system first and check if everything is fine, and then you can move ahead, burn that code according to the simulation that you have, and build your hardware according to the simulations component that you choose, and then start running your hardware and all, right? So again, before, instead of going to the PPT, let's directly go to the MATLAB, and I'll just show you like, oh, come on. Where is, no, why NXP is not here? Okay, so where we are, let's go open the MATLAB. Now it should open. Fine, thank you. Like that is a very big software, so it takes some times to open based on your computer configuration also. Let me just close the other things which I'm not using now to make sure that all the resources are available for the MATLAB. Done. Okay, so come on, running, still running, still running. So let's open a Simulink. So and MATLAB also from the NXP side, we have we have MBDT tool, which is a MATLAB-based model-based development design. So you can go to the NXP website and look for the MBDT, and then it will throw you options that model-based design toolbox. It is nothing but it actually, there's a download button. When you download, then it will give you the all the MATLAB files and everything that's tools and which is integrated to the MATLAB. So one of that is here from the MBDT tool. It will act as an add-on. So it will actually give you uh, the for the board or the processor wise, all the examples and everything that is available on the MVD tool that you can look into it. And then it gives an examples also. like what are the examples for this processor is available. You can choose those examples, uh, and can run the model, like say just let's say just open any of this, and then you have .mdl. It's open here. So your peripheral block has been used as a model it gives. So when you start building your code, then you can start building, choosing, picking up all these peripherals and the complete control systems and everything. This is when you download the MBDT tool that you'll see everything's are there, and then when you have those the embedded coder, then it when you do the build, it generate the code and burn the code to your MCU. So you first uh, open the MATLAB, make a system, simulate that system, see all the result is fine, then build the code and burn this directly code to your hardware. So it actually bypass a lot of other things and makes your life easy, and make sure that whatever things you are doing, you are first simulating it, making sure that everything is correct before burning to the hardware, to make sure that hardware will not misbehave, should not misbehave, or should not go bad when you start running it, right? Because most of the times you'll have like where you're working with the high voltage or the high current and all. If you do something wrong, then your hardware will go bad in the next moment as soon as you start up your hardware. So it's always good to have first simulate it to make sure that everything is perfectly fine, and then burn to the hardware. So okay, it's taking some time. So then it'll burn the code to your hardware, and then you can run the code and check the performance and all. Hey. Oh, sometimes it takes a lot of time. Oh, it's a heavy tool. Come on. We need to wait once that is finished. So it's compiled the code. Now it's burning into the hardware. Come on. Download complete. Please restart the board. So done. It does everything from his side. Okay, so you see, right? It gives us all the files and everything that you can integrate to your projects finally for your applications. So this is one of the things I have just given you a very just introduction that what is MBD tool, that once you download, you can explore it. It's an ocean. It's a lot of things are there. You can look into it, and based on your applications, you can start building the blocks based on the MBDT tools. So let me just close it and move to the other things that I would like to show. Now to the Simulink. The Simulink is actually from the MATLAB, where you do this simulations, and let's say go to the blank model and see in the library, the Simulink, there will be a library, and it will give you all the things in the block format. So there's a two-way that you do simulations for your systems. Uh, the control systems or whatsoever it is. One thing is that you start picking up those blocks and put those and do simulations, or the other way is that you would write a code for that, all the simulations that you want to do, and then run the simulations. I'll show you the both. The one thing is, first thing is this. Let's say uh, just a one small simulation we want to do, and there's the simulations block that you want to see, like what are the blocks that are available. The one thing is that one way that you can go to the each and every sections and can look into it. It will show you that what are the blocks is available for you for the simulations. You can generate your own block also, by the way, if you don't know. Like you can make your own block, make your own logics, and compile it and make it as a block, and can save your Simulink, where you can use in the later part of your projects and something like that. Other way is that if you know the kind of name that what the block would be, so you can do final search, and it will throw you that okay, the step what are things related with the step this one. So here it is. So I'll just show you how to do that. Come on, where steps are gone? Oh, come on, let's go. Say the step. Um, let's say now I want to use as a filter. All the options for the filters are there, right? You can see that all the options are there. You can choose any. Let's see. I'll I'll go for the transfer functions to make it more clear. Transfer functions and see what other blocks are there for the transfer functions. These are the blocks are there. When you write any transfer functions, these are the blocks are there. So you can select. Let's say by transfer function with initial output, transfer function with initial state. Let's say transfer functions. This one. And to see how the variable is in your simulation results and all, then you have a scope. So you can choose a scope and can see the variable. So you can put it here. It's a simple drag and drops that you can use it. Or then you can I'll just trying to show you one simple 1 minute. Let's not connect directly here. So now there's two way that you can let's say I want to see the directly the impulse waveforms, how it's behaving, as well as when the impulse passing through the transfer function, how this impulse output is behaving. So either I can go here, double click the scope, and then in the scope I can go for the number of variables I want to use here, or let's say number of inputs, one or two or three input I want to see. If I make it 1 minute, okay, so it was one. If I make it two, then it will have option for the two variables to be have it. So let's go with the only one, and I'll show you the another way. So in this, the two variables, the two different scope would be there. So I have one, and let's say I'll do the mux, and I'll mux both these two input variables, and can see by superimposing one input to the other and see exactly how these two are behaving. So I just connect it here, and this is one here, and let's run it and see how it's behaving. You can see. So this is the step, yellow one is step response that I have provided, and this is the output. So now if you see in the transfer functions, there is a option that you can choose. Either you have initial value to some value, or you can make it to 0, or then this is a transfer function that you want to choose. If you want to make it much faster, let's make it the integral very low, and then apply. Then the transfer functions will be this, and now you can see the response has been changed, right? And let's say in my systems, this integral is very high, so I'll make the integral part big, and let's see how the system behaves. You can see it's going way beyond, like it's not at all reaching to the point that the input is. The output is not reaching the point. Let's just reduce this to the 5 to just see if it is reaches to the output. Okay, so it's reaching, right? If I just reduce further, so if I just reduce further, make it is make it 2. It is reaching much longer times it is taking, but it is reaching. The other things which I would like to show is apps, no, model model setting. It does actually MATLAB does is it does the calculations of your variable in each and every point that you ask them to do that. So there are the two various ways. There is variable step or the fixed steps, and then variable steps. There is a various way to solve that equations. So you can choose the one which is best suited for your application or your simulations block. So it is not like that each block will be best suited for the in any kind of simulations or the Simulink block that you have chosen. So you need to know that what are the simulations you want to do, what are simulation block that you have, and what is the best suited the solver method it will be to give you the exact results. Let's say if you choose this one, so by default it will something else. And if you want to go with a much accurate result and see each and every point that how the system is behaving, you need to choose the uh, you need to choose the right solver and the solving methods and everything. So it will give you. So this is one of the way that you do simulate your systems. So I have just given example. So there are that you can build your system and do. Now if you see here, there's a lot of blocks are there. So whatever things he wants to make, like you can generate the pendulums, you can have like pulse, you can have a discrete, you can have a continuous signals and all. So whichever things you can think of and your logics fit for, so almost everything's the blocks are here. You can directly pick and place the blocks in your systems, connect those blocks as your systems required, and then run your simulations. So there is a Simulink block, and then there is a lot of things like in the communications toolbox. There are a lot of things are there, and then for the mixed signals, every block is there. So I have not used all the blocks, so I'm not going to all blocks. Like in a control system, there is a blocks are there that you can use the matrix and everything that to solve the equations. Uh, then there is a Simscape. Where is Simscape? So there is a lot of functions are here. Electrical functions, motor, and everything will be there. For the power electronics guys, all these things are there. For the electrical functions are there a lot of that you can use it. For like so for the BLDC motor control, you have complete the blocks here. You can just connect it systems and it will give you the outputs. So let's say if I just pull it here and see what is there inside, you can actually you can look into the in the blocks also that what is there inside. If you just click it here in that block, it will give you that what are things are there that you need to provide those parameters as per the requirements, and then the blocks will run correctly. Otherwise, it will give you the wrong results. So this is one of the way, and other way is that I'll just show you for this one. There is as I said, like there's a two way that you can do the simulations, and the other way generally I used to do is that write my equations based on my circuit. Right, I have a circuit. In my circuit, there will be inductor, there will be capacitor, there will be resistors, and how this for every switching points, how those things are getting related to each other. Then I can have those ones, and this will actually give me the my control loops. Come on, it is here it is. ZVT. Okay, so let me see. It's here. Okay, all are there. So I can choose what are the my the gain bandwidth and my phase margins and everything's here. What is my sampling rate? And based on that, what are the equations would be there, and then the equation from that equations, what is the value going to be my KP and KI for my control loop, basically for the control loops. And then I can if I run it I'll add to this path. Mm, oh, keep running. So it will draw you a border plot also. You can see your gain and phase margins, your bandwidth of your systems that for your design if it is there or not, and based on if you change the value of your parameter, then how those parameters been getting changed. Let's say for this. it's giving me all this value of this KP and KI and everything. And let's say if I just change it here, parameter, let's say I don't want to go with the 125 kilohertz switching frequency. I want to go with the 150 kilohertz switching frequency. And let's see how much, let's go to the 200 kilohertz switching frequency and see how the system is behaving. If I just run it again, it will recalculate all my system's parameters and it'll give me the border plot, and can I give it a just of hints that how my control system will be behaving in the actual system. What will my phase margin, what will my gain margin, and everything should be there. If you recall your uh, class studies of the control systems. So see, this KP and KI value has changed. This change. My transfer functions for the calculation has been changed. Everything is change based. If I just change my switching frequency from 150 to 200 kilohertz, and this is the things are there. So this is the one way that you can simulate and see the results of your control systems simulation in the Simulink. And the other way that we have showed you that you can pick all those blocks, the inductor and the capacitors and all and put it there and then simulate and see how these variables are behaving. Okay. So with this, I think we have come to an end of the session. Thank you. And